In this example, we have f of x is -4 cosine of cosine x to the fourth. And we need to find the derivative. We have some nested functions here. So let's call this function here h of x. And that's the -4 cosine. But inside the -4 cosine, we have another function. We'll call that g of x. And then inside that, we'll call that k of x. So when we take the derivative, we're going to have to use the chain rule. And we're going to have to use it twice because we have some nested functions here. So when we look at f of x as composition functions, we have h, and then instead of saying h of x, I'm going to say within h I have g of x, but within that x I have k of x. So this is the x to the fourth. This is the inner cosine. And then I have this here, which is the outer cosine. Now, if I were to write this, the derivative of this, if I take the derivative using the chain rule, I would have the derivative of h with our nested functions times, and then I would have to take the derivative of what's inside, and then I would have to take the derivative of what's inside g, so I would have this. Okay, now when I actually go to take that derivative, when I'm looking at that outer function, h of x, I have a -4, but I'm taking the derivative of cosine, which is negative sine. So the two negatives make that a +4 sine, and then inside it stays the same. And then I have to multiply that by the derivative of the cosine of x to the fourth, which is negative sine x to the fourth. And then I have to take the derivative of the x to the fourth, which would be 4x to the third. Now, when we simplify this, I'm going to take this negative, because this is all multiplication, I can change the order. But the negative is going to go out front to clean it up a little bit, and then I'm going to take this and multiply together. So in front, I'm going to have 16 x to the third with a negative. Then I have sine of cosine x to the fourth, and then I have sine x to the fourth.